Here, PIC 18 contributes to the process of examining with various timers that are very supportable, and the area starts over here, which is a continuation video. And in this continuation video we see the power timers, power of timer, oscillator, startup timer, power on reset, watchdog timer, brownout reset, and file safe clock monitor. So here all these things states one idea of splitting the timer with respect to some internal sources. That is, we start from here, power of timer. So the power supply given to the timer, oscillator startup timer, initial kickstart for the oscillator is given. That is, oscillator signals are enabled. Then power on reset. So whenever you reset, the timer is initiated from where you reset. So all these things are one idea. That is, you are powering up the timer, then continuing it and resetting it. Then watchdog timer. So watchdog timer will try to synchronize with all the timing sensors and brownout reset. So this is a total reset of the watchdog timer. If you want to entirely reset the total microcontroller setup, you can go for a brownout timer. So this will try to revamp or initiate a watchdog timer. If suppose watchdog timer may get crashed at some time due to some unavoidable interrupts. Then fail-safe clock monitor. So these are all pretty like you take it in a way that if a fuse is placed somewhere, if any error happens, the fuse gets burnt. But we don't know where the short circuit happened and how the loop was interrupted and how these things went. We don't know actually. But fuse helps us to cut off. So all these things are in that manner. So watchdog timer is a band gap reference. Okay, and or here. In this internal oscillator block, so internal oscillator block is present, which gives oscillator circuitry 1 and oscillatory circuitry 2. Then timer oscillatory 1, timer oscillatory 2. So 8 megahertz oscillations and internal oscillations, all these things are given as an oscillatory circuits. Then field supply programming and in circuit debugging. So all these gives a way to split things, and the split is governed in this manner. The way that the in circuit operates, followed by USB. So USB voltage regulator. So USB voltage regulator helps to govern the voltage regulator for all the peripheral ports. That is, for all the peripheral ports like USB. For all the peripheral ports like USB, we hold these things, and these things have some idea of connecting the way it actively activates. And USB is a serial universal serial bus communication, and every port seems to be an universal serial bus. As said in class, the serial data is the data that is being transferred through the ports, and the port will help to do all those steps. And port may create some idea of understanding the data, acquisition of data. So for all those understanding and acquisition of data, it need to appear in a serial form. That is serial communication, starting with 0, ending with 7. So all these steps will give some contribution, and the contribution is something like making ourselves things even more better in the way we understand, and the data is a serial form of communication. Okay, what I said, the data is a serial form of communication. So, when the data is a serial form of communication, it will deal with things over here. That is serial form of communication, that is USB, and ADC, that is analog to digital, and digital to analog converters. Then universal synchronous asynchronous receiver transmitter, that is UART, USART, and comparator. So all these areas work under one idea, that is, it all deals with the fundamental idea of creating a scope for understanding of serial data transfer. So the data is transferred serially. So that's the main idea. The data is transferred serially. So either it happening in the port, or either it is happening in timers, or either it is happening in the watchdog timer areas, or split of these oscillator signals, that differs according to the usage. So on the whole, this 18 PIC microcontroller deals with a complete split of 8-bit data, first point, and all those 8-bit data split will work with lower and higher order, second point. Third point is it all deals with the timers of various USB, UART, and ADC comparators. Then fourth one is all these need to be stored in stack pointer, program counter, and those steps. So it makes a great iconic idea of creating a big amount of work to be split into a solid 8 bit. So when when a data is being split into a mm, micro level split, it actually works so fast because you already know how the data would be. You already know how much memory space it will utilize. You already know where to store the data and where to retrieve the data. So the speed becomes unmatchable when comparing to 16, only due to the idea of identifying the data and address as a single 8-bit contributor. So this is the idea of this PIC18 microcontroller and strength of PIC18 microcontroller. So this 8-bit holds strong in serial data transfer because unanimously the data is transferred from 0 to 7. So idea is very clear. So this completes the video. Thank you.